On Earth, we have a lot of water locked up as ice. Particularly the poles, you get really big piles of ice, and we call those ice sheets. These ice sheets are great indicators of what's going on with our climate. So there's a lot of investigation. Are they melting? Are they not melting? Because if they do melt, they raise sea level, and that affects everybody in big ways.
It's the edge of the glacier right here. Co?
Yeah.
Go straight over the glacier right here.
We're at the Russell Glacier, which is a small outlet glacier on the edge of the Greenland ice sheet. A glacier is ice in motion. It's flowing under its own weight. If you were to stand here with a camera day after day, what you would see is the ice marching towards us and falling off and falling on. When we say the Greenland ice sheet is melting, the way that happens is the outlet glaciers speed up. When the outlet glaciers speed up, more ice breaks off in the fjords. It's not as if the entire surface of the Greenland ice sheet is melting. The actual melting of the ice, most of that takes place at the coast.
Yeah, for Greenland, what we're seeing is quite a bit of change, and I think a lot of the change is surprising a great number of scientists. You know, all glaciers around the world are melting, but they don't hold all that much water. Greenland has about 7 meters of sea level equivalent, so if that ice sheet melts, all of it, we'll get 7 meters of sea level rise. That's over 20 feet. If the West Arctic ice sheet, the one down in the southern hemisphere that we're worried about, melts, that could give us 5 meters of sea level. So up to about 40 feet of sea level could result if we melt both of these ice sheets. It's pretty important to look back at the last time sea level was higher than present day, because you want to figure out, could we in the future go across that threshold?
We're standing here in one of my favorite places in the world, which is Windley Key Quarry, Florida, in the Florida Keys. And if we had been here 125,000 years or so ago, we'd be underwater by several meters. What you see here in the quarry walls on either side of us here is a rock called the Key Largo Formation. It's a limestone, and about 30% of it is composed of corals that were once part of a living coral reef that formed about 125,000 years or so ago during a period we call the last interglacial. This is a remarkable example of a brain coral in its original growth position. Diploria, or brain corals, are one of the most common constituents in the modern reef off Florida today and here in the Key Largo limestone. The top of the coral head is here, and you can trace this along the sides down here to the base of the coral. The top of the quarry here, and very close to the top of this brain coral, are about 5 meters above sea level. And brain corals need to grow in water at least 3 meters deep or so. So that means that sea level has to have been probably anywhere from 6 to 8 meters higher than present during the last interglacial period. One of the most powerful things about the geologic record of sea level change is it does answer the question, is such a thing possible? We know it's possible because it's happened in the past.
Well, it's not hard to take what we know about the height of coastlines to get maps showing, as sea level rises, which areas will get flooded where. Here's a visualization showing the Earth and the areas in red that would be submerged with 6 meters of sea level rise. So 6 meters of sea level doesn't sound like very much, but it'll affect a very large part of the world's population and landmass. When we zoom in to finer spatial scales. It allows us to put a more human face on the sea level rise that could occur in the future. We can actually see individual communities that will be submerged by sea level rise. Science is never certain. What science is all about is trying to figure out what's probable, what's not probable, and to be really open with what the uncertainties are. In this case, we know the sea level was higher in the past. And we know that was because the Earth was warmer, particularly in the northern hemisphere, over the Greenland ice sheet. The big question is, how much warmer was it? And both our climate modeling and our paleoclimatic reconstructions suggest it's somewhere between 3 and 5 degrees C is the temperature by which a lot of Greenland will be melting fast. But to put it in a little perspective, 3 to 5 degrees, how long will it take us to get there? Just in the last 50 years, we've warmed up the Arctic by over 2 degrees. So we're more than halfway to 3 to 5 degrees. And sometime later in the century, we'll cross that mark. In our work, we don't know for sure where the threshold is beyond which the ice melting is inevitable, but we know it's coming, and if we don't do something about greenhouse gas emissions soon, we're going to cross that threshold, and future generations are going to have to deal with that big sea level rise.